Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasriq Raduan. I'm gonna representing my groups to present our project entitled Stable Marriage and Coupon Collecting. So basically, stable marriage problem is a problem to determine the best set of matching between instances. Those instances should have the same number, and every instances should have a priority of choice. Like the example below, Mary, the first choice of Mary is John, and John, the first choice of John is Tanya. So everybody has their own choice, and the number of men and women is the same. 4 men and 4 women. Okay, the objective is we want to match the man and the woman based on their priority and based on the demand they have between them. Okay, this problem can be applied in others problem when we want match a newly hired staff to the priority of skill and department which required certain skills. Okay, what we want to avoid in this problem is someone who have priorities choice doesn't get that. For this example, Freddie like Mary. So Mary is his first choice. But for Mary, Freddie is the last choice. Roger is her first choice. But Elizabeth got Roger for the first choice, but Roger doesn't get Mary for his first choice. And this not going to make a stable marriage. This we want to avoid actually. Okay. So the first thing we try is using randomized algorithm. There are some methods in randomized algorithm. For the first is like this. Randomized algorithm will generate random selection out of problems. Random selection is being made in the range of n number of total selection for each instances. The problem considered solved when the iteration of random selection finish once the range is finished. Okay, this is the example. For the first iteration, Freddie choose Mary, Roger choose Elizabeth, John choose Jennifer, Brian choose Tanya. And for the second, the choice is made by random by the machine. The choice is made by the machine using random algorithm. So in the second iteration, the first choice is being marked like this. So for the second iteration, the machine will choose again for each person. Like Freddie choose Tanya, Roger choose Mary, John choose Elizabeth, Brian choose Mary. So the same goes to the next iteration. The machine will not choose what have been chosen in the last previous iteration until all of the choices they have been chosen, and the last choice is the final choice. Like Freddie choose Jennifer, Roger choose Jennifer, John choose Mary, and Brian choose Elizabeth. The problem with this algorithm is it might end up like Freddie and Roger still competing for the same lady, Jennifer. So it has this is the drawbacks of this algorithm. Okay, next. So there are some solutions for the algorithm, the randomized algorithm. For example, in this solution, okay, for the solution for the randomized algorithm, this algorithm improvised by the table is made two like this, man table and woman table. So here we can see the competition between them. If they have the same person choose between them, so they have to do another iteration. So in this solution algorithm, for the randomized algorithm, they need to propose one of the women based on random selection. It's still based on random selection, and but the algorithm will only stop when every man has wife and no more people without partner. So let's look at the solution randomized algorithm. So it's made like this. For the first day, every man select a random woman to propose. So Freddie choose Tanya, Roger choose Elizabeth, John choose Jennifer, Brian choose Tanya. Okay, so rejection and proposal. The day one, still day one, but next phase is rejection of proposal. So we see here, Freddie and Brian choose the same woman, so they choose Tanya. So at the rejection of proposal phase, Tanya have to choose between Freddie and Brian. Okay, of course, Tanya will choose Freddie because Freddie at her first choice, and Brian will be rejected. Okay, so let's see. Okay, the day of engagement, Brian will have no partner. Freddie will have Tanya because Tanya have choose Freddie over Brian. And Mary has no one proposed for her. So for the first day, 3 couple got engaged. Freddie with Tanya, Roger with Elizabeth, John with Jennifer. Okay, that's all. Brian and Mary has no one. So because there's still person who got rejected and not selected, so they have to have second day of iteration. So the second day of iteration, they start with the first phase. Like the first day, the one who got no partner have to choose another one randomly, like we used to do. So Brian chose Jennifer because only Brian doesn't have any partner yet, right? And Mary, of course. But Mary can't choose. Just man can't choose. So Brian choose Jennifer. Okay. When Brian choose Jennifer, because Tanya got crossed, because Tanya have choose someone else, Brian chose Jennifer for the second day. In the rejection of proposal phase, we can see that Jennifer and John and Brian competing for the same person, even though John and Jennifer has already got engaged. Jennifer has to choose again between Brian and John. So of course, Jennifer will choose Brian. Jennifer will choose Brian over John because Brian is at his third choice compared to John at his fourth choice. So here John get rejected by Jennifer. So Brian got partner, but John now has no partner. So let's see. Okay, Brian got Jennifer, John got rejected. So here, the one who have no partner, John and Jennifer. John and Mary, because Jennifer divorced John and Jennifer got married, engaged with Brian. Okay. So now, let's see. Because John doesn't have partner, we have to do the third iteration and so forth. So at the third iteration, John, everybody else who already have partner, they don't have to choose anymore. The only one who have to choose randomly again at the next iteration is who have no partner, such as here in this case is John. So John have to do the next iteration, choosing another person for his lifetime partner. John this time randomly choose Elizabeth. So we can see that Elizabeth has been chosen by Roger. So Elizabeth have to choose again between Roger and John. Let's see Jennifer. Let's see Elizabeth. Elizabeth now got proposed by Roger and John. So he have to choose. Yes, he stick with Roger because Roger is at her second choice compared to John at her third choice. So John get rejected again. So the one who have partner now is still John and Mary. Okay, just the same. John still have no partner and Mary still have no one choose. So we have to do the third iteration. Now John choose Mary. Mary, let's see, Mary, no one choose Mary. So they all have partner already. So that's it. Everybody have partner and everybody in average got their second and third choice, except for Brian got her fourth choice. Same as woman. For woman, they average got their first and second John, first and second choice, except Jennifer get her third choice. Not bad. This not bad, right? This algorithm. So the other solution is they not choose randomly. The only problem with choose partner randomly, they got no option to choose what's the first choice first they want. So in this other solution, they don't choose randomly, but the machine will choose for them their first choice first. Then if in the first choice they have some competition and argument, it has to be brings to another iteration like the previous algorithm. So let's see for the first day of proposal. Freddie, Roger, John, Brian propose for their love of life. Freddie choose Mary, Roger choose Mary, John choose Tanya, Brian propose Mary. We can see 3 men go for Mary. This is the problem. So, of course, Mary will have to choose one of them. And Mary choose Freddie because Freddie is her second choice compared to others, third and fourth. So, here we can see only Freddie and Mary got married, engaged, and John and Tanya. So, Brian and Roger got rejected. because they have to compete with Freddie, but Mary choose Freddie. And Jennifer and Elizabeth, no one choose them, so they have no partner yet. Here we have only two couples got engaged, so we have to go to another day, another iteration. Okay, Freddie and Brian, they don't have to choose in this day. Only Roger and John, because they have no partner. Okay, Roger choose Elizabeth. It's go turn by turn. Roger go for her second choice, Elizabeth. Brian go for Roger go for his second choice, Elizabeth. Brian go to his second choice, Elizabeth also. So you see a problem. So Elizabeth have to choose between Roger and Brian. Of course, Elizabeth will choose Roger here. Elizabeth will choose Roger here because it is her second choice compared to Brian, last choice. Okay, now three couple settle. Now just Brian got engaged for 2 times. Mary and Elizabeth already reject him. So he have to do the third iteration. He choose for her third choice, Tanya. Tanya also got engaged with John, but Tanya have to choose again. So we can see here, Tanya already got engaged with John, but Brian come and propose Tanya, so Tanya have to choose. Tanya choose Brian because Brian is her second choice. So here, for the third iteration, John get rejected and Brian settled down with Tanya. John have to choose his second choice for the fourth iteration. For the fourth iteration, John competing with Roger for Elizabeth, and Elizabeth have to choose here Roger or John, and Elizabeth choose Roger. So now John have to go for the fifth iteration for Mary. Mary now got married with Freddie. But let's see, Mary choose who? Between John and Freddie? Yeah, Mary are so lucky to have her first choice. Now John proposed for Mary, and of course Mary will go to John and left Freddie. Now Freddie have to go for the sixth iteration and choose Jennifer. Okay, we should do it. We don't have any problem now. Jennifer not got anyone, right? Jennifer, just Freddie. So they all settled down. 4 couple got engaged and married. So that's I think the best solution, because everybody got, for the men got between 2 and 3rd choice, and for the woman get between 1 and 2nd choice. Compared to the previous algorithm, they got lower priority of choice. Here they got better. So that's all for the stable marriage problem. The solution, we got 3 solutions here, and we think the best is the 3rd one. And this algorithm can be applied to another problem, such as when people applying for university or medical student who have finished their study, selecting for their place, hospital, to be working as a houseman, to do their housemanship. So this algorithm can be used and applied to select for them, to manage their proposal to the hospitals or to the universities. So that's all from me. My friends will continue with the second problem. So thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shalihin. So for our project about the stable marriage and coupon collector problem, I will continue from my friends Nasriq. So I will present about the coupon collector problem, which is the second problem in our project. So coupon collecting is, for example, it means that we want to collect a set of object, and what is the effort needed for us to collect all the object in the set. So in this coupon collector problem, the goal is to purchase distinct objects in order to make a complete set of objects. This purchase of object, each purchase give random object, and the contents of the purchase are independent of all other purchase. It is not just for coupon, but object collected can be any kind of object. For example, ticket, toys, cards, any object that we want, but in a set. Same object, same type of object in the set. So in mathematics, this problem is to quantify what is the effort needed to complete the collection of objects. This can be done by calculating the expected value of purchase of an object in order to obtain a full set of those objects. For example, in this application, for collecting toys, this toy can be collected by pack. The pack will be sealed. For example, these toys, each pack contain single toy, meaning one of the 3 toys that can be chosen at random. These 3 distinct toys in the set has an equal chance to be in each pack. So the each pack is independent of every other pack. The application of this problem is to calculate the expected value of number of packs one will need to open in order to obtain at least one copy of each toy, mean the complete set of toys, all the 3 toys. So for the complexity of this problem, one of our observation, we find that it is interesting. Why? Because when one of the problem is when the collection becomes approaching a complete collection, meaning that the final item we want to get requires more effort to obtain, meaning for each item, meaning the more this item we get, the more difficult to complete the collection. So the mathematical principle behind this problem are useful for problem involved different types of things. Like I just said, cards from collectible card game, sport card, toys, ticket, any other things electrical that we can get to complete the set. So what is the solution for this problem? The solution of this problem, we will use the randomized algorithm, which there are several steps to get the number of times we need to complete set, mainly the part needed. So first, let xi be the random variable representing number of draws between I minus 1 distinct coupon and I distinct coupon. This x be a random variable reflecting the number of independent Bernoulli trials needed to observe the first success. This occurs at the cat trial follows the geometric distribution with for the first question is probability x equal to k is equal to p 1 minus p to the power of k minus 1. So there are two probability we need to have, which is probability of drawing unseen coupon and drawing a seen coupon. So let pi be the probability of drawing an unseen coupon and I draw. The question is pi equal to n minus I plus 1 divided by n. Next is qi, probability of drawing a seen coupon is equal to I minus 1 divided by n. Thus, to sum it, the probability of taking k draws to get the I unseen coupon is as followed from the independent between draws. Probability xi equal to k are equal to pi plus by qi to the power of k minus 1. xi is a geometric random variable. X number of coupons drawn until all n distinct coupons show up, which is what we want to find. Distinct coupon n. Note that x equal to n I equal to I xi number of n. By linearity of expression is follow that expectation x equal to numbers of n I equal to 1 times expectation x I. To find the expression of xi, the equation, as you can see, the last we get is n divided by n minus I plus 1. From this we can find the expected number of coupon drawn until all n distinct coupons show up, which is simply the sum of all e. Expectation xi for all I equal to 1 until n. As you can see, we do this, then the final is n log n. This is the number of coupons drawn until n distinct coupons show up, which is the complete set of object. So that is all for my presentation about the coupon collecting problem. Thank you and Assalamualaikum.